All right. When you think about AI, what comes to mind? Probably something like, an AI that can spot a cat in a photo, right? But what if an AI could create a picture of a cat that has never, ever existed? See, those two things, recognizing and creating, they're not just different tasks. They are two completely different philosophies in the world of AI. Today, we're going to dive into that story, generative versus discriminative models. So, here's the game plan. We'll start with how machines see the world. Then we'll get into the big debate, generative versus discriminative. After that, we'll see how this theory actually works in the real world. And finally, we'll have a little showdown to see what's what. Okay, so let's kick things off with a classic problem. How does a machine learn to tell these handwritten digits apart? I mean, for you and me, it's a piece of a cake, right? But for a machine, think about it. That's actually a really, really tough thing to teach. Just look at all the different ways people write. I mean, my two probably looks nothing like your two. Every single number has its own little personality, its own little quirk. So teaching a machine to see all that messiness and still say, yup, that's an 8, well, that's one of the fundamental challenges in AI. We call this classification.
Okay, but now flip that coin. What if, instead of just recognizing a 2, a machine could invent a totally new one from scratch, one that no human has ever written before, or a human face that doesn't belong to anyone, or a piece of music? Now that is a whole other ballgame.
So right there you have it, two totally different goals. On one hand, you have recognizing what already exists. On the other, creating something brand new. And this isn't just about different tasks, no. This is the story of two completely different philosophies in AI. So let's break this down. We've got generative versus discriminative models, learning the whole story versus just learning the differences. To really wrap our heads around this, let's try a little analogy. Imagine you need to figure out what language someone is speaking. You've got two basic strategies you could use. All right, so the first strategy, the generative one, is, well, it's the ambitious one. You decide to learn every single language from scratch. We're talking grammar, vocabulary, the rhythm, the whole shebang. You would actually understand how to generate a sentence. Now, the discriminative approach, it's much more practical. You just learn the key differences. You figure out that French has a certain sound, German has another. You don't learn to speak them, you just learn enough to tell them apart. Okay, so let's connect that analogy back to the real tech. A generative model is our fluent speaker. It wants to learn the whole story. In nerdy stats terms, it learns what's called the joint probability distribution, or P of x comma y. All that means is it's trying to figure out the probability of some data x and its label y occurring together. And because it understands that deep connection, it can then go on to generate brand new, believable examples of its own. Then you've got the discriminative model. This is our pattern spotter. It's not trying to learn the whole language. It's just looking for clues. It learns the conditional probability, or P of y times given x. Basically, it asks a much simpler question. Okay, given the data I'm looking at, x, what's the probability that the label is y? It couldn't care less about how the data was made. All it wants to do is find the line, the decision boundary, that separates one class from another. Let's make this super concrete. Check out this table. A generative model wants to understand the probability of every single box. It's trying to build a complete map of the world. So it asks, what's the chance that x is 1 and y is 0 at the same time? Well, in this little world, it's 1/2. What about x being 2 and y being 1? That's 1/4. The really important thing here is that if you add up all the numbers in all the boxes, they have to equal 1. It's modeling the entire universe of possibilities. Now, contrast that with the discriminative model. It takes a totally different view. It doesn't care about the whole map. It just looks at one road at a time. It says, okay, if I know that x is 1, what's y? Boom, 100% chance it's 0. And if x is 2, well, then it's a 50-50 toss-up. See how each row adds up to 1 by itself? It's not learning the whole picture. It's just laser-focused on learning the rule to get from x to y. All right, so that's the theory. But, this isn't just stuff for textbooks. These two philosophies are the engine behind a ton of the AI we interact with every single day. So let's jump from theory to reality and see where these models are actually used. First up, discriminative models. You can think of these as the absolute workhorses of machine learning. We're talking about things like support vector machines, logistic regression, decision trees, the classics. Their job is straightforward classification. Is this email spam or not?
Is this transaction fraud or legit? They're built for one thing. Look at the data, make a call.
And this image is a perfect example of what they do. This is what a support vector machine, an SVM, is trying to accomplish. Its entire goal is to draw the best possible line, or in this case, a curve, to separate the two groups of data points. It is literally discriminating between the circles and the crosses. That's its whole job.
Okay, now for the other side of the family, the generative models. This is where things get, well, a lot more creative. Here you'll find things like naive Bayes or hidden markup models. But the real superstars of this group, the ones you've probably heard of, are things like VAEs and, of course, GANs, Generative Adversarial Networks. These are the models that can paint, write, and compose. They don't just predict, they create. And when you look at how these generative models are represented, they often look like these complicated network diagrams. What they're trying to do here is build a kind of blueprint of the data. They're not just looking at the surface. They're trying to figure out the deep down underlying structure, the rules that actually generate the data in the first place. It's about modeling the whole system, not just drawing a line through it. Okay, so we've got two very powerful but very different ways of thinking about AI. The big question is, which one's better? Well, let's put them head to head. It's time for the final showdown to see their strengths and weaknesses. This chart really lays it all out. Your generative model on the left, it learns the whole probabilistic story of the data, that P of X, Y. Its superpower? It can generate new data, and it's often really good when you don't have a ton of data to work with. Now, the discriminative model on the right, it's a specialist. It just wants to find that decision boundary, P of Y given X. This usually makes it more accurate for pure classification. But there's a trade-off, right? The discriminative model can be a bit of a black box. We don't always know why it made a decision. The generative model, on the other hand, can sometimes give us a much richer understanding of the data's hidden structure.
So when it comes down to it, the goal here really isn't to pick a winner. No, it's all about choosing the right tool for the job. It's that simple. If your job is to tell spam from not spam, you grab a discriminative model. It's efficient, it's direct, it gets the job done. But if you want to create a brand new world, generate faces for a video game, or write a poem, well, then you absolutely need a generative model. But that leaves us with a really big, kind of mind-bending question, doesn't it? For so long, AI was mostly about sorting and labeling the world, discriminating. But now, with these incredibly powerful, deep generative models, we are squarely in an era of AI creation. So what happens when our AI can generate art, code, and text that's just as good or maybe even better than a human's? Does that change the entire job of AI itself? We're shifting from simply understanding reality to actively generating a new one. What happens next when that line starts to get really, really blurry?